Hello, welcome to a special Maths of Lloydie series. We are looking at common entrance exams. These are for year 8. And the pen is not choosing to play dice. Here we go. So if you're in year 8, if you're taking it early in year 7, I don't think many of you would, especially when I've had a look at that additional paper. You might want to avoid it. Of course, the channel is Maths with Lloydie. Let's make sure we spread the word and get plenty of subscribers. So in this video, we're looking at the core non-calculator paper. When we go through this, when I say question 2, what I'd like you to do is sort of pause the video maybe, if you've got the paper in front of you, have a go, and then hit play in order to mark your work as you go through. So that way you can kind of have it modeled to you if you don't quite get it correct, and you can mark it correct if you do. The things in the front here for long answer questions, marks will be awarded for working. Answers should include correct units when necessary. If I'm honest, every bit of the mark scheme says use the correct units, so that's something I'll be trying to get across as we give our answers. Answers given as fractions should be reduced to lowest terms and written as mixed numbers. Now, I do a lot of starters with my classes on 4 operations with fractions. That's what I always want. So that is good practice to do that. Okay, so here we go. Question number 1. Write the number which appears, or write the number which each arrow points to on the number line. So we've got 5 to 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 bits between them, which means that we've got 5.2 just in there for A. For B, it's between 5.3, 4, 5, between 5.6 and 5.7, which makes it 5.65. And then for C, it's just between 6 and 6.1, so it's going to be 6.05. Write these numbers in order of size, starting with the smallest. So our smallest number, because there is nothing in the units column, 0.87. Then we've got 3 numbers. They've got 8 in the units column, but in the tenths column, the 1 makes that one the smallest. We've got 8.6, followed by 8.7. And then our biggest number is 87. That's the only one that's above 10. Write the correct sign between each pair. We've got the less than, the greater than, or the equal to symbol. So these two are equal to, because 5.8 and 5.80 have the same value. 5/8 and 5/9. 5/8 is going to be bigger. If we were to turn those into decimals, I'm pretty sure this one gives us 0.5 recurring, and this one gives us 0. Now I'm testing myself, 625, I believe. Okay, and then again, these ones, this simplifies down to 3/4, making those two equal as well. Okay, question 2. Work out. So I'm going to risk it. I'm not going to pause it as I go. Going to make sure that I get through this video because I have made all my notes. I'm happy with my answers. So again, we're looking at order operations. This is bid maths. And from this first question, if you do it left to right, you're going to get it correct anyway, because 10 times 7 is 70, and then take away the 4 is 66. But you're not here because you want to just get a couple of marks. You want to get the whole sort of question right, and you want to be moving forward and getting big marks. Now with this one, we've got addition, and then we've got multiplication. So we do that multiplication first. 4 times 3 is 12, and then we add the 5 and the 12 together to get 17. Now, part C has got lots of little bits happening to it, but again, we follow bid maths. So we're going to have 8 take away, and we sort out this bit. 3 times 5, which is 15, add 7. Now, bid maths has always had like a little asterisk with it. And the asterisk is that when you get to the addition subtraction, you just go left to right. So we're not going to do the addition first because it's like before the subtraction in bid maths. We just go from left to right. So 8 minus 15 is minus 7. And then when we add those two together, we get to 0. So just be very, very careful of that. Question 3. Use the fact that 18 multiplied by 24 is equal to 432 to complete the following. So with this first one, this is sort of divide by 10. This one's divide by 10 from that original. So our answer is going to be divided by 100, meaning that 432 will become 4.32, moving that decimal place 2 spaces to the left. Okay, 18 times by 48, that's 24 times by 2. So we're going to have double the answer that we had on that initial part of the question, giving us 864. 19 times by 24, so that is 18 plus 1. So we're going to have to add an 18 onto it. So 432 plus 18. 0, carry the 1, 3, 4, 5. That's really thrown me. I've done the wrong thing. Okay, let's work out what I've done wrong. So this is 18 plus 1, which means we're not adding 18. We're adding an extra 24. So 432 plus the 24, 65, 456. I'm glad I've done that as well. I'm not going to delete that because it's very important that you always check your working, have a think about it. And I'm really glad that I've shown you that. Okay, 432 divided by 240. So 432 divided by 24 will equal 18. So if we make that 10 times bigger, the answer is going to become 10 times smaller, 1.8. Okay, question 4. We'll do this one and then I will pause it. 0.7 times by 1.2. Now, going back to the earlier part, to that front sheet, it says we have to give our units every time. That's why there's 4 marks in here. So they're going to knock some marks off, as I reckon, if we don't give our units. I am going to find it a lot easier to multiply if I've got 0.7 meters and 1.2. So 0.7 times by 1.2. 0.7 times by 0.2 is 0.14, and then I can add the 0.7 onto that, which gives me 0.84. So my answer there is 0.84 centimeters squared. For the triangle, base times by height divided by 2. Our height is 15, our base is 16. Now I can kind of cancel these early doors and have 15 times by 8. 15 times by 8 is 120 meters squared. Part B, calculate the perimeter of the triangle. 16 plus 17 plus 17, which gives us 50. 2 marks for this, so our units are meters. Okay, I'm just going to pause it, and then I'll be back for question 5. Okay, question number 5. I won't lie to you, pausing that video is very helpful because I've got my sandwiches, got my drink, sort of just refresh myself, and then let's go again. So part A, 4's into 9.4. I'm going to zoom in because it's very important that you use these squares wisely. 4's into 9, going twice with a remainder of 1. 4's into 14, 4, 8, 12, 16's too big, so it goes in 3 times with the remainder of 2. So we add a 0 on at the end. 4's into 20, go in 5 times, so 2.35. Part B, 48.6 plus 4.86. So as you can see again, I'm using the squares and using them to have the numbers in the correct columns. And of course you can put some placeholders in if you want to. Just remember that decimal place is not moving its position. 0 plus 6, 6. 6 plus 8, 14. Carry the 1. 8 plus 4 is 12, plus 1 is 13. Carry that 1. And then we've got 5 at the end, so 53.46. Now, I don't know if you're going to like my method for multiplication. And if you don't, I don't care. Because this gets the correct answer every time. And you don't need to do anything more than 9 times 9. I appreciate some of you have a column method for this. I don't touch it with a barge pole. So what's happening is we've got our decimal place here and here. So if I just change my colour, where those two meet, if you draw a little squiggly line, will be where that decimal place comes out. And then in these grids, you just do the multiplications and put the tens in the left side and the units on the right. So 7 times 6, 42. 2 times 6, 12. 4 times 6, 24. And then you count the values of these numbers in these diagonals. So you've got a 2. 4 and 2 is 6. 1 and 4 is 5, and then there's a 2 there, which gives us 256.2. I wouldn't do it any other way. If your teachers are not teaching you that method, it's called Napier's bones, also known as the Chinese method. Research it. You can multiply 10-digit numbers by 12-digit numbers, and that method for the decimal place will get that into the right position. The only thing we've not really covered here is if we had to do any carrying, and then you just add the value into the next one and include it. So it just works so well. Right, question 6. Change these to percentages. Ideally, we want them to be out of 100. So 5 times by 20 gets you to 100. So you multiply the 4 by 20 as well, which gives you 80% for that first one. For B, again, we want it out of 100 because percent means like per 100. Century, for those of you who follow cricket, very important number, very important word. 25 times by 4 gives you to 100. So 8 times 4 will be 32. 32%. Right, question 7. Write each number as a product of its prime factors. I like to use the prime factor tree. Let's get that 10 out of the way. 2 and then 5. Got another 10 there. Oh, made a mistake. It's not 40, it's 45. Trying to rush it, ain't I? What a wally. Still. 9, 5, and then 3 and 3. So 2 times by... I'm naughty. I've got lazy. You circle those primes as you go. So 2 times by 3 squared times by 5 squared. That is now broken into a product of its primes. 105. Start off with a 5 to begin with. That's going to be 21. And then 3, 7. So that gives us 3 times 5 times 7. Do put them in ascending order also. Right, find the largest number that divides exactly into 450 and 105. And I had to stop and think about this one because they've used some slightly different language. Largest number that divides is going to be the highest common factor. So a 2, that is not common in either of these. I shouldn't do that over because that's my answer. Don't do that. So the 2 won't work. The 3, we have a 3, but we've only got 1 3 in each number. And then the 5, we've only got 1 5 as well. Because if I was to write that out, it would be 2 times 3 times 3 times 5 times 5. So 3 times 5 are the only pairs that we've got in both numbers. The 7 doesn't appear in the number on the left. And therefore, 3 times 5 is 15. Okay, I'm just going to pause here, take a breath, and we'll see you at question 8.